Hello. Hello, good morning.
Good morning, sir.
Okay. Uh, because of network problem, there will be issue to start the lecture in a time. No problem at all. In last lecture, we have already started the fluid power symbol. In fluid power symbol, we studied different symbols used to represent different devices in a hydraulic as well as pneumatics. In hydraulic system, we have studied different elements, that is the power generating element, control element, and power output element. In power generating element, we studied the pumps and hydraulic pumps and hydraulic motors. In control element, we studied the pressure control valve, flow control valve, and direction control valve. And output control elements, we studied the different actuators. It may be a hydraulic and a rotary. It consists of rotary actuators like motors, hydraulic actuators like cylinders, right? And we see different symbols used for different devices. Also, certain accumulators and intensifier we also studied. So, while going for the hydraulic circuit design and studying its applications of hydraulic circuit, we must know the what are the different elements of the hydraulic circuit and how they are represented symbolically. Likewise, in last lecture, we focus on how pump and motors are symbolically represented. Then we see the various conditions of the pumps, that is fixed displacement, unidirectional, bidirectional, variable displacement. These symbols we have studied in last lecture. And the graphical symbol for the cylinder is also shown in this diagram. Then direction control valve, it will be shown in this diagram. Pressure relief valve, flow control valve, and non-return valve. Also, there are certain methods of actuation for the cylinder are shown in this diagram. These are the some graphical symbols used for the energy transmission. Then, how accumulators are to be represented symbolically, how pressure gauge, how the measuring devices are shown symbolically, it will be shown in this diagram. So in last lecture, we have covered all these symbols. Now in today's lecture, we will start with our third unit, that is the hydraulic circuit, in which we have to study different types of the hydraulic circuits which are used. In content, it have simple circuit, speed control circuit, meter in, meter out, bleed off circuit, regenerative circuit, sequencing circuit, synchronizing circuit, counterbalancing circuit, and certain circuits which are taking a use of accumulator and intensifier. Also, we study some specific application, that is the clamping circuit, hydraulic clamping circuit, hydraulic braking circuit. Okay, is my voice is audible?
Yes, sir.
Yes, sir.
Okay, so we start with a simple circuit, right? If you are considering any type of the hydraulic circuit, it mainly have three parts. This is the energy generating elements or input part. We may call it as the input part. This one. It consists of reservoir, filter, pump, motor, and this pressure relief valve and this pressure gauge. This is the input part. Central part, it is the controlling part. It consists of a control valve. It may be a it consists of a direction control valve, right? It may consist of a flow control valve, right? It may consist of a pressure control valve. And last one, that is the output element. It consists of a mainly a actuator. It may be consist of a cylinder arrangement, and rotary motors are there. Hydraulic cylinder and motors are there, right? If you are considering a single acting cylinder, consider this diagram. And now you are well known about the various symbols we are used in hydraulic circuit. Some names are given nearer to that symbol, so they will be identified. This will be the filter, this will be the reservoir, pump, motor. Pump always connected with a motor. Pump is called as a prime mover. It requires some external source to run it. So we will supply the energy by using the electric motor or IC engine. Then this will be the pressure relief valve. It will set the system pressure. Uh, System pressure it will be set at a particular point. Means by using the pressure relief valve, we can operate this whole hydraulic system at a set pressure. So this pressure relief valve it will be act as safety valve. So whatever the all the elements involved in this hydraulic circuit, they are operating at a certain set pressure. We may say 10 bar. Below 10 bar, all these elements of hydraulic circuits, they are operating smoothly, right? So this pressure relief valve, it will provide the set pressure for overall the system. Then this is the pressure gauge, and this is the shut off valve. Shut off valve, it will be like a basin valve. Means we can allow the flow to the by rotating the knob, we can allow the flow to the pressure gauge in order to measure the pressure. Otherwise, it will be always in closed position. Then this will be a direction control valve. Which type of direction control valve? Because as it is having a two sphere, so it will be a two position and three port P, R, C, P, R, and A. So there are three port two position valve, and it will be operating by using this lever. So this is the lever operated 3/2 direction control valve. And last element, that is a this is a cylinder where it is having one port, so it will be a single acting cylinder, and it is a spring return. Spring it is mounted at a rod end side. So how will we explain this diagram? Yes, when we are starting this motor, it will run pumps, it will suck the oil or fluid or liquid or oil from the reservoir. It gets filtered through this filter, then it is passing through this line. Its pressure is measured by using this pressure gauge, by using shut-off valve. If the pressure from the pump outlet it is more than the pressure at the system, set pressure of the system, at that time this pressure relief valve it will sense the pressure at the outlet of the pump, which is the more than the set value. At that time, this valve it will be gets operate, and surplus fluid it will be again back to the reservoir, right? Otherwise, the outlet from the pump, the fluid coming from the outlet of the pump, it will be passing through P port to this A port to the cylinder. Means on a left hand side of the piston. Because of that, this piston it will be moving in right hand side. So this push force it will be happening, right? This is the first position for the movement of the piston for the push force. When we are operating this lever, at that time this position it will be actuated. At that time what happen? Whatever the fluid coming from the reservoir by the pump, it will be passing through the P port to the A port. But A port is now where A port it is a closed one. P port it is a closed one. Sorry, P port it is a closed one. So whatever the fluid coming from the pump, it will be directly drained to the reservoir through this pressure relief valve. And whatever the fluid which is present over here, because of the spring action, this piston is moving in a backward direction. That is the pull force because of by the spring. So whatever the fluid present over here, it will be coming from port A to port R. That is a reservoir. Means this is the normal position or pull force where hydraulic circuit we are using for single acting cylinder. Are you getting this explanation regarding this diagram or simple hydraulic circuit? Hello?
Yes, sir.
Okay. Can you draw this diagram? Hello?
Okay, sir.
Hello? प्रज्वल,
Yes, sir.
Yes, sir.
एक 10 मिनिटाचा ब्रेक घेतोय मी काय. ऑल आर रिक्वेस्टेड टू बी प्रेझेंट फॉर दिस लेक्चर. माझे शेजारचे जे आहेत ते एक्सपायर झालेले आहेत. एक 10 मिनिटात मी जाऊन येतो तिकडे.
हाँ सर.
आता ते डायग्राम व्यवस्थित काढून घ्या. मी एक 10 मिनिटात रिटर्न येतो. वाटलं तर पुढची डायग्राम मी ऑपरेट करून द्यायला लावतो. तुम्ही ती ड्रॉ करा. मी 5 ते 10 मिनिटात बॅक येतो. हा.
ओके सर.
Hello, hello.
Yes, sir.
Yes, sir.
Okay. Is the diagram is over?
Sir, screen is not visible.
Hello. Now, now whether it is visible?
No, sir.
Hello. Please reply. Is it visible? Screen is visible?
Yes, sir.
Okay, okay. Have you completed this diagram? Hello. Have you completed this diagram? Hello. Hello.
Yes, sir.
Hello. Okay. Have you completed that diagram? First diagram? Have you completed this diagram?
No, sir.
Okay, complete it. Is it over?
Yes, sir.
Okay. Now we will go forward for the next circuit, that is a speed control circuit. In speed control circuit, we are controlling the speed of the actuators, that is a cylinder. By providing certain kinds of the flow control valve and inlet side of the cylinder. So that circuit is called as the metering circuit. If this flow control valve it is mounted at the outlet from the cylinder, then it come under the category of a meter out circuit. And if this flow control valve is mounted after the pump and before supplying to the cylinder or after coming out from the cylinder, then such type of the circuit is called as the bleed off circuit or bypass circuit. In bleed off circuit, we are providing the flow control valve in the bypass line of the circuit. These are the basic three types: meter in circuit, meter out circuit, and bleed off circuit. Is voice is audible? Hello?
Yes, sir.
The speed control circuit, graphically it will be represented as like this. Meter in circuit where we can provide the flow control valve at the inlet of the cylinder. Meter out circuit, we are providing the flow control valve, variable flow control valve at the outlet of the cylinder. And bleed off circuit where we can provide the flow control valve at the bypass line which is going to the reservoir. So that circuit is called as a bleed off circuit. I think this part I have covered in last lecture, previous lecture.
Yes, sir.
Hello. Whether this part is covered?
Yes, sir.
Reply please. His voice is audible?
Yes, sir.
Okay. This is a diagram for the meter in circuit. Here, in meter in circuit, we are providing this variable flow control valve with a check valve. This is a built-in check valve म्हणतो आपण. Variable flow control valve with a built-in check valve. It is mounted at the inlet side of this cylinder. So this diagram, it will indicate meter in circuit. Because of that, the movement, forward movement of this piston, it will be controlled by using the controlling the fluid flow by using this variable flow control valve. Now how it works? Here, as we know that this is the pump, this will be the motor, this will be the pressure relief valve, this will be the direction control valve. Which type of direction control valve? 4 ports are there: A, B, P and R. 4 ports and 2 square, 2 positions. So this is a 4/2 direction control valve. And actuation method, this is a symbol of a solenoid operated 4/2 direction control valve. And this is the variable flow control valve. And there will be one valve, that is a check valve. It allows the flow only in one direction, in downward direction, towards the ball side. Toward the arrow side, it will be blocked. So this check valve, it is always built with a variable flow control valve, and it is mounted at a inlet side of this cylinder. This is a double acting cylinder because there are 2 ports on either side of the piston. Right? Now how it works? When we start the motor, pump will suck the liquid or oil from the reservoir. It is passing to the direction control valve. If the pressure of this liquid, it is beyond the set value of the system pressure, at that time this pressure relief valve, it will be actuated and surplus fluid or liquid, it will be drained to the reservoir. Otherwise, it is always, it is in a closed position. It is in inoperative position. Whenever the pressure in a system, it will be goes beyond the set pressure value. If this overall system is operating at 15 bar pressure, up to 15 bar, this pressure relief valve, it is in a inoperative condition. If the pressure in a system, it will be crosses the 15 bar, then it is reaches up to 16, 17 bar. At that time only this valve, it will be gets operated. Whatever the pressure in a system, it will be sensed by this pilot signal. If this sensor senses that the pressure in a system, it is now 16 bar, at that time only this line, it will be connected. So this valve, it will be operating and surplus fluid, it will be drained to the reservoir. And we have to maintain the pressure in a system by diverting certain amount of fluid to the reservoir and maintaining at a set pressure, that is a 15 bar. That fluid is now passing through this flow control valve. Right? When it is passing through this check valve, this direction of the check valve, what it shows, the upward direction flow, it will be blocked. So whatever the fluid coming from the direction control valve, it is passing through this flow control valve, variable flow control valve, where we can adjust the flow rate passing through this valve by rotating the knob of the flow control valve. So control amount of a flow, it will be supplied at the inlet of the cylinder. Accordingly, this piston, it will be moved in forward direction. So by controlling the inlet flow to the cylinder by using the flow control valve, the speed of the piston, it will be controlled. So this type of a circuit is called as a metering circuit. In other side of a piston, what happen? Whatever the fluid which will be present in a rod end side of the cylinder, it will be passing through this B port to R port to reservoir, where it will be get filtered by using return line filter, and finally it will be passed to the reservoir. This is the speed control when piston advances. Advances means moving in a right hand direction, or it is called as an extension stroke. Means extension stroke of the piston can be controlled by providing control amount of fluid by using flow control valve and built-in check valve. When we are operating the solenoid valve, at that time what happen? Second position it will be active, where the flow from the pump, it will be now passing to the B port. Because of that, piston move in a reverse direction, or retraction stroke is to be carried out. At that time, whatever the fluid which is present on the left hand side of the piston during the extension stroke, now it will be passing through this A port. Now part of the fluid now passing through this check valve. Now this flow path of this check valve, it is a free to flow. Because of that, almost all amount of the fluid coming from the A port, instead of passing through this flow control valve, it is passing through this free flow check valve, and it will be passed to this B port to the R port to the reservoir. In this way, this metering circuit, it will be operating. Are you getting the operation of metering circuit? Hello?
Yes, sir.
What is the advantage of this metering circuit? Where it is to be used? The metering circuit, it is used in a cylinder where constant pressure and positive load, constant and positive pressure or load, it will be required. At that location, we are using metering circuit. Is it clear? Metering circuit. What is the main drawback of this
Yes, sir.
system? When the oil is passing through this flow control valve, heat is generated, and this generated heat, it is provided to the actuator. Because of that, whatever the seals which are present toward the piston head side, its life, it will be get reduced. That will be the disadvantage. And another one, at one side of the piston there will be pressure, on another side there will be less pressure as compared to the left hand side pressure. Because on a left hand side of the piston, the fluid is coming from the pump, and pump is generating very high pressure. So on left hand side of the piston there will be high pressure as compared to the right hand side of the piston. So because of that, pressure imbalance it may happen. So movement, it will maybe erratic movement of the piston rod. This is the disadvantages of the system. Are you getting this metering circuit? Hello?
Yes, sir.
Please draw this diagram of metering circuit. Everyone must have to draw this diagram. Diagram is clearly visible?
Yes, sir.
Hello? Okay, okay. Do it. You must have to remember the position of the check wall in meter in diagrams here. Upward flow is blocked, but downward flow it will allow the fluid, right? Means pointer is toward the upward side in case of a meter in circuit. We see same position of the check wall in meter out circuit. So we will get the difference. Is it over? Hello? Whether diagram is over?
Yes, sir.
Okay, which point you have to remember in metering circuit? First one, we must require this variable flow control wall with a built-in check wall. Is it clear? Second, in case of a meter in circuit, we have to mount this variable flow control wall with the built-in check wall at the inlet side of the piston. Where the pressurized fluid from the pump it will be in this type of the meter in circuit. When fluid from the pump it only passes through this flow control wall. As we are connecting this check wall in a such a way that the flow through the cylinder through this check wall it is a block means upward flow is blocked. So all of the fluid coming. So whatever the supply of the flow to the cylinder, it will be controlled by this variable flow control wall. If we are supplying 100 liter per minute, then this piston is moving moving in outward direction at a very fast. If we are supplying 10 liter per minute, at that time the movement of the piston, it will be a very slower one. So this meter in circuit, it will be utilized for the slow movement or precise movement of the piston within the cylinder. Whenever precise speed control circuit. At that time, whatever the fluid from A, now it will be passing directly through this check valve. It does not passing through this flow control valve. At that time, this flow control valve, it will become as a standby or inactive. So no speed control, it will be carried out during the return stroke. Speed control can is means extension stroke of the piston. At that time only speed control is to be carried out. During the return stroke of the piston, there will be no speed control because the speed variable flow control it will be inactive approximately. Whatever the fluid from port A, it will be passing असेल तर हा चेकच होत नाही बा because the flow from the check wall it will be blocked over here. It does not allow the flow. This direction it should be a reverse one in this case. This flow it will be blocked. So जे काही फ्लुइड येणार आहे पंप कडून हे सगळं तुम्हाला ह्या फ्लो कंट्रोल वॉल मधूनच पास कारण इथला फ्लो हा ब्लॉक केलेला. आर यू गेटिंग? हॅलो Deep Jyoti, are you getting this point?
Yes, sir.
Yes, sir.
Okay. Now we will take the attendance in chat box, division 8. Roll number 63.
Yes, sir.
Adam Sheikh is there? Okay. 31 Pratik. Hey, Rutik Godse. Roll number 31.
Yes, sir.
Okay. Now write the B division students. Write your roll in chat box. B division student. B, Sarvademukh and Kadam. Is it clear? Rai, Bhandare, Mani. Anyone is remaining? Hello, is it over from A and B division? Anybody is remaining? Pranav is there?
Yes, sir. Yes, sir.
Pranav Bhandare?
Yes, sir.
Okay. Okay. Is the voice is clearly audible to you, all of you? Okay. And now we will move toward the next circuit, that is the meter out circuit. Whether this diagram is visible clearly, meter out circuit?
Yes, sir.
Okay. You can easily understood the difference between these two circuits, right? What change we have made? Instead of providing variable flow control wall at the inlet, we are providing variable flow control wall with inbuilt check wall at the outlet of the cylinder. Is it clear? Is it clear? Means
Yes,
what
sir.
happens if you are observing this diagram? What is this R for? R for R notation
Reservoir.
for? Okay. F for filter. P for pump. S for setup wall. G for gauge. PRV for pressure
Pressure
relief wall. Okay. This is the 4x2 direction control wall. Button operated, push button operated 4x2 direction control wall. Now see here, this is the first position, this will be the second position, right? What happens when we are starting this pump? The fluid is passing through this direction control wall, through this P port to A port to the left hand side of the cylinder, right? At that time, whatever the fluid which will be previously present at rod end side of the piston, it will be coming out from this B port. Now it is passing through this variable flow control wall and check wall. When the partly fluid, it will be passing through this check wall. The flow from this check wall, it will be blocked in downward direction, right? Whatever the fluid that will trying to pass through this check wall, that flow is blocked. So again, this flow coming back, and all of the fluid coming from the port B, it must be passing through this variable flow control wall, right? And after that, it will be passing through this port B to this port, that is the R or reservoir. It is directly coming to this reservoir. Are you getting? Here, there will be a reservoir port. Are you imagine that? This is the port P. P for coming from pump. This will be port A. A is the A port of the cylinder. This is the B port. B port of the cylinder. And this is the R port. R for the reservoir. P R A B. we have seen in a symbols, right? Bottom ports, it is for the left hand port, it is for the pump, right hand port for the reservoir. Top la left hand port, it is for the A, right hand port for the B. Now see here, when we are passing toward the right hand side, flow can be controlled by controlling the flow coming out from the cylinder. Then you are controlling the knob, or by rotating the knob of the flow control valve, variable flow control valve, we can control the flow coming out from the cylinder. म्हणजे you can control the amount of flow coming out from the cylinder. For that purpose, this circuit is called as a meter out circuit. Means whatever the fluid coming out from the cylinder, it will be get metered, it will be get controlled. So this circuit is called as a meter out circuit. Because of this meter out circuit, we can control the extension or forward movement of the piston. So if you are allowing this flow control all totally open, at that time very fast movement of the piston toward the right hand side, its speed it will be reduced by the half. If we are reducing, we are opening the flow control valve very slightly, at that time the speed of this piston within the cylinder, it is a very also. Means by
Sir,
controlling this, yes, hello,
sir, your voice is disturbing very much.
very much disturbing. Okay, now is it audible?
Yes, sir, but in middle only it's not audible.
It's happened because of range problem. I'm facing very much problem in range. Okay, I would. Can I repeat this diagram?
Yes, sir, a little.
Okay. In a meter out circuit, we are providing the flow control valve at the cylinder. It will be gets metered or control its flow by using this flow control valve. Because of that, the movement of the piston, it will be, its speed can be controlled by controlling the amount of flow coming out from the cylinder and does not check valve. The position of the check valve mounting, it will be such that the downward flow, it will be a block valve. So whatever the total amount of the fluid coming out from the cylinder, it must be metered through this flow control valve. Because of that, meter control valve इनलेट साईडला वापरला, त्याच्यामुळं सिलेंडरच्या इनलेटला जे काही फ्लुइड पास होत होतं ते मीटर होत होतं, म्हणजे त्याला फ्लो कंट्रोल करत होतो आपण त्या फ्लो कंट्रोल वाल. याच्यामध्ये काय करतोय आपण, सिलेंडरच्या आउटलेट मधून जे काही फ्लुइड बाहेर पडणार आहे त्याचा फ्लुइड फ्लो रेट आपण काय म्हणतोय मीटर आउट पिस्टनचा एक्सटेन्शन स्ट्रोकचा स्पीड आपल्याला कंट्रोल करता येतो. नाव when you are operating this push button at that time this position it will be actuated. There what happen, the flow from the pump now it is passing from port P to port B. Now it is passing through this flow control valve. So metering of the fluid it does not happen over here. So that fluid it is coming to left hand side. So retraction stroke it will be carried out. Side of the piston it will be coming from port A to port R. R for reservoir or drain. So there will be no speed control when during the when piston is moving in a reverse direction. Means there will be no speed control during the retraction stroke of the piston. So these are the diagram. This diagram. Hello. Hello.
Yes, sir.
Whether my voice are you understood meter out circuit? Hello. Shraddha, are you there? Shraddha Gajko,
Hello, sir.
have you understood?
Yes, sir. Sir, your voice was talking too much.
Meter out circuit. Okay. In meter out variable flow. Okay. Then how you can say that you will be get understood all these two circuits, meter in and meter out circuit? Hello. Now is it audible? Hello. Deep Jyoti is there?
Yes, sir.
Have you understood meter out circuit?
Yes, sir.
Okay. What is the difference between meter in and meter out? Hello, Deep Jyoti.
Sir, that variable
Hello.
flow control is present at left side in meter in circuit, and that variable flow control valve is present at right side in meter out circuit.
Okay, very nice. But technically, you have to tell that instead of left and right, inlet to the cylinder and exit to the cylinder. For the left, you may tell at the inlet side of the cylinder. That will be meter in circuit. And at the outlet side of the cylinder, when flow control wall is there, then that will be a meter out circuit. Are you getting?
Yes, sir.
Okay. Whatever this meter out circuit they are used, they are explained in this diagram. Particular naming operation or tool, constant movement of the tool, which will be visible by using the meter out circuit. Are you getting? Now we will go for the next type of the circuit, that is a bleed off circuit. Have you visible this diagram?
Yes, sir.
Diagram is visible.
Yes, sir. Diagram is visible.
What change we have made in this diagram? See here. Okay. In a bleed off circuit or bleed off speed control circuit, we are mounting this variable flow control valve. This variable flow control valve, or it also called as a bleed off valve, in a bypass line coming out from the pump. It does not mounted at the inlet of the cylinder, also at the point of this piston. It will be mounted at a bypass line of this circuit. So, in case of a bleed of speed control circuit, we are mounting this flow control valve at the bypass line of the circuit. How it works? Here, in this type of the circuit, whatever the fluid sucked by this pump, it will be passed to the cylinder or actuator for the forward and backward movement of the piston by using this direction control valve. But we can control the direction of the piston on either side by using this bleed up type valve. Now, how it will be possible here? When pump is operating, at that time fluid is sucked from the reservoir through this filter. Now, whenever you have to control the forward movement of the piston, if you require, if this pump is operating at 15 bar pressure, and you have to supply this 15 bar pressure at the left hand side of this piston, at that time this piston it will be moving at a very fast speed toward the right side. But in certain applications where we require to move this piston, at that time we have to reduce the amount of fluid supply toward the left hand side of the piston. At that time, whatever the fluid supply is there, here the fluid coming out from the pump, some part of the to the reservoir instead of it will be passing to the actuator. Is it clear or not? Hello, is it audible?
Sir, some students are saying that your voice is stucking.
Hello,
Sir, you are not audible clearly.
1 minute. I will use the headphone. Hello, hello, hello. Now I am audible.
Yes, sir.
Hello. Now voice is not stucking.
Sir,
Is it
still it is
clearly audible?
breaking.
Or still stucking the voice?
Yes, sir, still
Ah,
breaking.
say something deep closely. I am not getting you. Still breaking.
Sir, your voice is fluctuating. It's sometimes sounding and it's sometimes not coming.
Hello. Now is it audible? Hello. Hello. Please reply.
Yes, sir, you are
Saurabh.
audible now.
Ah, Deep Jyoti. Now is it audible?
Yes, sir.
Okay, okay. Control circuit. We have to bypass some amount of fluid coming out from the pump directly to the drain in order to control the amount of fluid supply on either side of the piston in order to control the speed of the piston. For that purpose, we are using this lead of speed control valve. Main difference in this type of valve here. In metering circuit, we are providing flow control valve at the inlet of the cylinder. In meter out circuit, we are providing flow control valve at the outlet of the cylinder. But in bleed of speed control circuit, we are mounting this flow control valve at the bypass line, which will be coming exactly after the pump. So this bypass line we are providing flow control valve in order to bypass the fluid to the reservoir. Because of that, whatever the amount of control fluid we require to supply to the cylinder, it will be metered by using this flow control valve or bypass control valve, which will be placed in a bypass line that will supply the surplus or partial amount of fluid coming out from the pump directly to the reservoir. If you are observing this diagram, see here, when pump is to be starting, now pump is providing 100 liter per minute to the A port at the left hand side of the piston. At that time, speed of the piston, it will be a 10 meter per second. 10 meter per second. Now, we have to require that speed up to 5 meter per second. In order to obtain that speed, 5 meter per second, what we have to do? We have to bypass some amount of fluid coming from the pump. Now, instead of 100 liter per minute, we have to allow 50 liter per minute to the left hand side of the pump. For that purpose, whatever the 50 meter surplus, that will be passed to this bypass control valve, and it will be passed to the drain valve. So only 50 liter per minute it will be supplied to the A port. Because of that, the piston it will be moved with a speed 5 meter per second. So by using this bypass control valve or bleed off circuit, we can control the speed on both sides of the piston. Now, whatever the fluid on a piston rod side, it will be coming from port B to R to direct reservoir. Means by using the bypass control, we can control the forward stroke of the piston. For return stroke, what happens here? We are passing this fluid to this port P to port B on the right hand side of the piston. When piston, it will be moved in a backward side or retraction stroke it will be carried out. So whatever the fluid on a left hand side of the piston, it will be coming out from port A to a reservoir. This will be the retraction stroke in case of a bleed off speed control circuit. Means in case of a bleed off speed control circuit, whenever you have to control that speed, whatever the fluid sucked by this pump, some part of the fluid it will be bypassed. So limited amount of fluid we can supply to the B port. So the retraction movement can be controlled by providing bypass valve or bleed off valve in a bypass line of this circuit. Are you getting the operation of the bleed off circuit? Are you getting?
Yes, sir.
Now total description is audible to all, or still we are suffering some problem of voice? Hello? You are suffering the problem. Hello? Hello?
Yes, sir, you are audible.
Okay. Can you get clear cut idea of the bypass valve? bypass bleed ऑफ आणि बॅकवर्ड मुवमेंट आपल्याला कंट्रोल करायची. त्यावेळेस आपण काय करतो, हा बायपास वॉल पंपच्या नंतर डायरेक्टली बायपास लाईन मध्ये माउंट केलाय. याचा उपयोग काय होतो? आता समजा हा पिस्टन 10 मीटर पर सेकंद ह्या वेलोसिटीने जातोय, तेव्हा जेव्हा हा पंप 100 लिटर पर मिनिट एवढा व्हॉल्यूम ऑफ फ्लुइड ए साइडनी सप्लाय करतो, त्यावेळेस हा पिस्टन 10 मीटर पर सेकंदनी पाहतो. जर मला ही वेलोसिटी कमी करायची, एक्सटेन्शन स्ट्रोक निम्मी करायची 5 मीटर पर सेकंद, त्यावेळेस मला काय करावं लागेल? इथं सप्लाय होणारं फ्लुइड त्याचा व्हॉल्यूम कमी करावा लागेल. म्हणजे तो 100 लिटर पर मिनिटच्या ऐवजी 50 लिटर पर मिनिट आणला पाहिजे. मग आता 50 लिटर पर मिनिट आणायचं असेल तर एक्स्ट्रा 50 काय करावं लागेल आपल्याला? ते बायपास करावं लागेल. राईट? म्हणजे इथून 50 बायपास केलं तर फक्त 50 लिटर पर मिनिट एवढा फ्लो फ्लुइड इथं येईल. त्याच्यामुळे ह्याची स्पीड, आउटवर्डची स्पीड काय येईल? निम्मी होईल. 10 मीटर पर सेकंडची 5 मीटर. रिट्रॅक्शन स्ट्रोकला तसंच आहे. जेव्हा हा पुश बटन तुम्ही दाबाल तेव्हा ही पोझिशन ऍक्टिव्हेट होईल. ती इथे दिसते तुम्हाला. पंपनी फ्लुइड सक केलं, आपण सप्लाय किती करणार आहे? 100 लिटर पर सेकंद. हॅलो, 100 लिटर पर मिनिट म्हणू आपण. त्यावेळेस स्पीड किती आहे? 100 मीटर पर सेकंद आहे. आता 100 तर 50 करायला म्हटलं इथून पुन्हा काय करावं लागेल आपल्याला? 50 लिटर पर मिनिट हा ब्लीड करावा लागेल, बायपास करावा लागेल फ्लो. म्हणजे इथून इकडे येणारं फ्लुइड जे आहे हे पुन्हा 50 लिटर पर मिनिट एवढं सप्लाय होईल. आणि रिट्रॅक्शन स्ट्रोक जो आहे हा 10 वरून 5 वरती, म्हणजे 5 मीटर पर सेकंड. मीन्स इन केस ऑफ अ ब्लीड ऑफ स्पीड कंट्रोल सर्किट we can control forward and backward movement of the piston by providing flow control valve in a bypass line of the circuit. Are you getting this? Are you getting?
Yes, sir.
And it will be used in broaching, shaping, and control circuit. Draw this diagram, please. Is the diagram is visible clearly? Clearly visible?
Yes, sir.
Okay. Draw it. When diagram is over, please reply. Over.
Yes, sir.
Any other student? Please reply. Anybody?
Yes, sir.
Prajwal, is it over? Sir Sagar is there. Sachin. Sir Sagar. Hello. Prajwal, is it over?
Yes, sir.
Okay. Now tell me, I want to control the forward movement or extension stroke of the piston by using a bleed off valve. Now what will be the location of this bleed off valve? Where it will be? समजते का माझा प्रश्न? मला फक्त फॉरवर्ड मुवमेंटच कंट्रोल करायची, पण ब्लीड ऑफ सर्किट आपल्याला वापरायचं आहे. ब्लीड ऑफ सर्किट. हा, बोला.
पंपच्या नंतर ना लावतात.
बरोबर आहे का? हा पंपच्या नंतरच आहे की, हा पंप आहे आपला, बरोबर आहे का? पंपच्या नंतरच हा लावलाय आपण.
हा सर.
बरोबर आहे. हा, त्याची आणखी पोझिशन कुठे येईल? आपण इथे माउंट करू शकतो, बरोबर आहे का? इथून डायरेक्टली रिझर्वायर, फक्त फॉरवर्ड मुवमेंट आपल्याला कन्वर्ट करायचं. राईट.
Yes, sir.
फक्त फॉरवर्ड, रिटर्नचे नाही. आणि ज्यावेळेस आपल्याला फक्त रिटर्न मुवमेंट कंट्रोल करायची त्यावेळेस हा इथं नाही येणार फ्लो कंट्रोल. पंप कडून डायरेक्ट येणार, इथून पंप कडून बी ला, बी कडून पुन्हा तिथं आपण ब्लेड ऑफ वॉल प्रोव्हाइड करणार आणि त्याचा ड्रेन आहे तो डायरेक्ट सेपरेट रिझर्वायर आपण इथं दाखवूया. राईट. थिंक दॅट डायग्राम विल बी क्लिअर हिअर. हे आपण आता प्रिव्हियस डायग्राम बघितली. फॉरवर्ड आणि बॅकवर्ड दोन्ही कंट्रोल होतं. त्याच्यामध्ये पंप नंतर हा ब्लेड ऑफ कंट्रोल वॉल येत आहे. पण ब्लेड ऑफ फॉर इनलेट टू द सिलेंडर असेल तर हा पंप नंतर न लावता, असा न लावता हा इनलेटला फक्त लावायचा. आर यू गेटिंग? Surplus fluid instead of passing to the inlet of the cylinder, part of the fluid it will be bleed off or bypass from the circuit to the reservoir. Okay. Are you getting this idea? Hello.
Yes, sir.
Now next one, that is a regenerative circuit. In a regenerative circuit, what is the main function of this regenerative circuit? When you are supplying certain amount of fluid at a port of the cylinder, it requires certain energy to move the piston towards the right hand side. राईट. म्हणजे ए पोर्ट मध्ये तुम्ही ज्यावेळेस फ्लुइड पास करताय, प्रेशराइज फ्लुइड, त्याची काहीतरी एनर्जी आपल्याला यूज करावी लागते हा पिस्टन फॉरवर्ड ढकलण्यासाठी. बरोबर आहे का? त्यावेळेस ह्या साईडचं जे फ्लुइड आहे ते काय होतं, डायरेक्टली आपण रिझर्वायरला पाठवतो. क्लिअर इन प्रिव्हियस डायग्राम. इथं पहा, इथं आपण फ्लुइड पास केलं की इकडून येणारं फ्लुइड काय होतं आपलं रिझर्वायरला जातो. राईट. But we require you to consume certain amount of energy to move the piston in a forward direction. And whatever the fluid which is present on a rod end side, it have certain amount of energy. It will be directly wasted by passing it through the reservoir. In a regenerative circuit, what we have done, the return or outlet from the cylinder, it will be reconnected to the inlet to the cylinder. Because of that, see here that diagram, whatever the outlet coming up from the cylinder, it will be reconnected to the inlet of the cylinder. Right. Inlet of the pump, outlet of the pump we may call. Outlet of the cylinder, it will be connected to the outlet of the pump. In next diagram it will be clearly seen how it will work. What happened because of that, the speed of extension it will be get intensified. म्हणजे समजा फक्त पंप कडून हा प्रेशराइज फ्लुइड आपण सिलेंडर ए पोर्टला देतोय त्यावेळेस हा सिलेंडर 10 मीटर पर सेकंड मूव्ह होतं. पण ह्या साईडचं फ्लुइड, सिलेंडरच्या आउटलेटचं फ्लुइड, हे पुन्हा आपण सप्लाय केलं कुठं पंपच्या आउटलेटला आणि दोन्ही कंबाईनली आपण इथं पास केलं तर हाच स्पीड तुमचा वाढतं. 10च्या ऐवजी तो 15 मीटर पर सेकंड होईल किंवा 20 मीटर पर सेकंड. मीन्स बाय युझिंग द रिजनरेटिव्ह सर्किट we can intensify the extension speed of the piston. Are you getting my point? Hello? Are you getting?
Yes, sir.
Means in order to increase the extension speed of the piston, we go for the regenerative circuit. And in a regenerative circuit, where the outlet from the cylinder, it will be given at the along with the pump outlet and combinedly it will be supplied to the inlet of the cylinder instead of it directly provided to the drain. Now here in this diagram, we will clearly understood how exactly it works. Now, what is this reservoir? What is this filter? What is this pump? What is this pressure relief valve? Now, which is this? Anybody can tell? What is this? Hello?
4x3 direction control valve.
Okay. 4 by 3 direction control valve. Central position, it will be now lock position, right? Off position. This position, when this lever operated, right? Lever operated 4 by 3 direction control valve. Now, central position, it will be off position. Now, when we are pushing this lever, at that time, this position, it will be come in actuation. What happen at that time? Whatever the fluid coming from the pump, it will be passing to this point, from this point to this E to A to left hand side of the piston. Because of that, piston it will be moving towards the right hand side. Due to right hand movement of the piston, whatever the fluid which is present in a rod end side of the piston, it will be coming through the port B. Instead of it will be directly drained to the reservoir, that fluid coming from the rod end of the cylinder, it will be again combined with the fluid coming from the pump. So, volume of the fluid flow, it will be increases, right? Because of that, what happen? The speed, extension speed of the piston, it will be increased. Now, when you are operating this position, what happen? Whatever the fluid coming from this pump, now it will be coming over port P. It will be port P. Port P to port B. Now this port B, it will be blocked, right? Because of a blocking, the pressure in a system, it will be goes on increasing because of a back pressure. So whatever the fluid pump by this pump, instead of going to port B, it will be again passed through this pressure. It will be coming back and it will be coming through this port. Then piston, it will be moving in a reverse direction. Then whatever the fluid on the left hand side, it will be coming at this location to the reservoir. समजतंय का हे दोन मोशन रिजनरेटिव्हच्या? क्लिअर. पंप चालू केला, प्रेशराइज फ्लुइड इथं आलं, ही पोझिशन ऍक्टिव्हेट केली. हा पी पोर्ट, तोच म्हणजे हा पी पोर्ट. तिथून हा कुठं आला? ए पोर्टला आला. हा ए पोर्ट म्हणजे आपला हा ए पोर्ट. इथून कुठं आला? ते फ्लुइड लेफ्ट हँड साईडला आलं. बरोबर आहे का? तिथं आता फ्लुइड येऊन साचायलं. इट विल मुव्हिंग द पिस्टन इन राईट हँड साईड. त्यावेळेस ह्या साईडचं जे फ्लुइड आहे ते इथून बाहेर पडेल. पोर्ट बी आहे. पोर्ट बी कडून आलेलं फ्लुइड एरवी आपण रिझर्वायरला पाठवायचं, पण ते वेस्टेज ऑफ एनर्जी होती. मग तीच एनर्जी आपण काय केली? ऍड केली. कशामध्ये? पंप कडून जे काही फ्लुइड आलं त्या फ्लुइड मध्ये हे फ्लुइड ऍड केलं, म्हणजे एनर्जी काय झाली? ऍड झाली. मग त्याच्यामुळे काय होणार आहे? जे काही फॉरवर्ड मुवमेंटला जे काही फ्लुइड जाणार आहे, राईट, इट्स व्हॉल्यूम इट विल बी गेट इन्क्रीजिंग. बिकॉज ऑफ दॅट स्पीड, extension speed, it will be goes on increasing. Piston extension speed, it will be enhancing or intensifying, right? Are you understood or not?
Yes, sir.
When you are operating this position, at that time what happen? Whatever the fluid coming from the pump, now it will be coming to port P, that will be here. Then it will be going to port B, that will be here. But port B, it will be blocked. Because of that, what happen? This fluid it will be coming back, right? This port B to port P, port P. Now it will have another branch to go for the port B. So fluid it will be passing on a right hand side of the piston. Because of that, piston it will be moving toward the left hand side. Due to the backward movement of the piston, whatever the fluid on left hand side of the piston, it will be coming from port A. Port A over here. That port is nothing but port A is there. From this A port to port R, and R is nothing but the reservoir. What I have to inform through this regenerative circuit, that whatever the energy or whatever the fluid coming from the B port or piston rod end, instead of it is wasting its energy by passing it to the reservoir, we can supply the fluid coming out from the cylinder end, cylinder outlet. It will be supplied in combination with the pump outlet at the inlet of the cylinder, due to which the volume of the fluid supply at the inlet of the cylinder it will be increased. That will help to increase the extension speed of the piston in case of a regenerative circuit. Are you understood?
Yes, sir.
Now draw this diagram. Regenerative circuit, name as a regenerative circuit, and draw this diagram. Whether diagram is visible?
Yes, sir, it is visible.
Is it over?
Yes, sir.
Everybody have drawn this diagram? Everyone?
Yes, sir.
Amol is there? Amol sir?
Yes, sir.
कुठले कुठले सर्किट बघितले आपण आज? Amol? Meter in, meter out, bleed off, regenerative. Is it clear? Yes, Amol.
Yes, sir.
Okay. Regenerative कधी वापरायचं? What is the function of regenerative? Anybody? In order to increase the extension speed of the piston, at that time you choose the regenerative circuit, right? Have you understood both all the 4 circuits clearly? Hello, have you understood?
Yes, sir.
Yes, sir.
Okay. Any query or any query related to these 4 circuits? Any doubt?
No, sir.
Shreyesh Chavan is there?
Yes, sir. Yes, sir.
Shreyesh is there?
Yes, sir.
Okay. Which circuit you like most out of 4? You understood very well. Shreyesh?
Meter in circuit.
Meter in circuit. Very nice. What is the problem for the meter out? Basic difference.
No
have you
problem,
understood?
sir. No. Yes, sir. Yes, sir. Yes, sir.
In meter in circuit, flow control valve, it will be mounted at a inlet to the cylinder, right?
Yes, sir.
In a meter circuit, it will be mounted at the outlet of the cylinder, right?
Yes,
In a
sir.
bleed off circuit, flow control valve, it will be mounted after the pump, right? In a bypass
Yes, sir.
line. In a bypass.
Bypass line.
And in, right, and in a regenerative circuit, what change we have made? Instead of passing the fluid coming out from the piston rod end of the cylinder, that is the B port, instead of directly passing to the reservoir, its energy it will be gets wasted if you are passing that fluid coming out from the cylinder end to the reservoir. Its energy gets wasted. Instead of passing to the reservoir, it will be supplied along with the pump discharge to the inlet of the cylinder, and it will be utilized to increase the speed of the piston. Which speed? Extension speed, that is forward stroke. Forward stroke of the piston, its speed can be increased by using the regenerative circuit. I think these 4 circuits are well understood to all of you. Is it clear? Have you drawn the diagram? Please watch the video on YouTube. If possible, I will show this video, its animations in next lecture or at the end of this chapter. All the animations we will see. Right? So for today's lecture, we will stop over here. Thank you for properly listening this lecture, and sorry for interrupting the during the first session. आपल्याच कॉलेजचा एक विद्यार्थी आहे मुलांनी म्हणून फर्स्ट इयरला आहे. तिची आजी तुम्हाला शेजारी राहतो. तिची आजी एक्सपायर झाली होती. त्याच्यासाठी आपण एक 5-10 मिनिटं थोडासा डिले झाला लेक्चरमध्ये. थँक्यू फॉर cooperation and thank you for proper listening. We will meet in next lecture on Saturday. Have a good day. Okay, we will stop here.
Thank you, sir.